Hello, and welcome to Build 2023. My name is David Harmon. I'm a Director of Developer Solutions with AMD. Joining me on stage today is Graham Burry with Microsoft. Graham.
Hi folks, I'm Graham Burry. I'm in the Microsoft Azure Compute team, specifically working on confidential computing. It's been 5 years since I've been at my last build, and I'm now working in this cloud computing and protecting data in use. It was just an early idea at Microsoft 5 years ago. Now we actually have some really cool offerings up and running. If you aren't familiar with confidential computing, I'm happy to give a little bit of an overview today to educate. As well, if you are familiar, I got some very cool news to share with some announcements. So thank you for joining.
Thanks, Graham. We're going to walk through today some technologies associated with AMD's roadmap, what we've got in market directly with Azure. But we want to make sure we get a history and an understanding of exactly where we are with AMD technologies. We're going to walk through some performance results associated with AMD EPYC products, some additional data center GPU products, and then walk into this, talk through some of the security initiatives that we're doing with Azure on our confidential VM solution. So let's dive right into it. So the next 5 years, if the next 5 years is anything like the last 5 years of AMD, we're going to continue again transform the market. Our data center and cloud growth year over year has been amazing. We're going to see that again with the explosion of AI, and we're going to continue as well have our PC and gaming for that cloud to edge solutions that ultimately the computing market is just going to demand. We're going to do this with some strategic pillars, unmatched compute technology. We've got GPUs, CPUs, AI, FPGA fabrics, FPGAs, and adaptive SoCs, and smart NICs. With our acquisitions this year, we're adding to our overall portfolio that has just really allowed us to adapt and really create a leadership portfolio for AMD-based solutions working with Azure and other vendors out there. One of those key innovations is MI250 and the AMD Instinct line from our data center GPU teams. This is a key product for us for HPC and AI. You might have seen some solutions recently. Back in November of 22, we created a very large supercomputer called Frontier. That thing's just an amazing product. We'll continue to do that. This thing has 4 Infinity Fabric links that connect the MI250 3rd-gen EPYC CPUs to enable unified CPU GPU memory. The coherency and maximize system throughput. This is capable of delivering up to 800 gigabytes per second with a total aggregate bandwidth, which is 2.3 times more than the previous generation. Another thing that we're specifically focused on right now with Microsoft is around AMD Ryzen AI. This is just recently with the Microsoft Studio Effects Pack in Windows 11, just another highlight of an overall cloud edge solution that we're working on. So our customers must demand that we deliver as promised. If that last 5 years, like we talked about, is going to be anything like the next 5 years in the computing space, we have to continue to deliver as promised. Back in 2017, AMD redid their entire server roadmap. We started off with Zen Core, 14 nanometer, 12 nanometer. That's based upon the I/O die compared to the compute die. With Zen 2 and 7 nanometer, and then Zen 3, and all the way up to Zen 4, where we are today is in 2023. Our customers, such as Azure, require that we actually deliver as promised and continue to execute as we have in the past to have any hope to make sure that we get the 2023 and beyond next 5-year promise. Just recently, with our latest launch back in November of 22, not too long ago, we launched our EPYC 9000 series, codenamed Genoa. This is the world's best data center CPU. It's industry-leading server solution, uniquely positioned for AI and overall just general workloads that scale from general purpose scenarios to HPC. It is the world's fastest data center processor. It's transformative energy efficient, leadership TCOs, which we'll kind of get into some of the details here in a minute, across workloads and industries, robust security, which Graham's going to talk through, what Azure's been able to do with our confidential VMs, and a rich ecosystems of solutions, all running on x86. Let's talk a little bit about performance. You can see in 2017, 2018 timeframe, We were competitive, but not competitive enough to really kind of steer a lot of decision makers. You can see from this chart, ever since then, we've just led all the way up to the right. You can see this is spec int graphed over time from all the way to 2022, and will continue on to 2023. This is critical. At our launch in November 22 with Genoa, Lisa Su, our CEO, stood on stage and talked about the 300 plus world records and still counting, and we've been doing that ever since. You can see the individual segments here with business apps, data management, analytics, engineering, technical, content, digital services, infrastructure, all areas of the ecosystem. With these 300 world records, we continue to, with the different solutions that are coming out, both within Azure and OEM-based solutions, even on Azure Stack HCI. Just to kind of compare this, since we're in the playoffs right now of basketball, if we were to do the final score of the final game, we'd roughly be winning by 321 to 50. That's just how far we ahead of our competition when it comes to performance and world records. On the general purpose front, we maintain performance leadership. You can see here 3x the performance. This is a 2P integer throughput spec rate 2017 base. Consolidate and match with 7 AMD servers compared to 20 of our competition, or 3x the throughput with 20x AMD. You can compare that to the second generation or 1.4x. So you've got your option to either consolidate down, use less servers to get to maintain the same performance throughput, or you can scale up and have that much more, depending upon what your use case are. Same thing for enterprise. 2P server-side Java, 1.5x with 3rd gen, and 3x with 4th gen. That translates to 60% fewer servers and still get the same throughput. 20 of our competition versus 8 AMD. You talk about TCOs, you talk about footprint, that really translate to our CTOs of the world at this point in time, really trying to maximize their space. Put it in comparison, put a little bit of a visual around it. You've got 15 servers of comparable x86 CPUs. That single rack on the left compared to 5 servers of 2P AMD EPYC 9654s. That calculates to a 3-year TCO infrastructure consolidation benefits. Look at these numbers: 67%, 52%, 60%, 40%. Fewer servers, less power, OpEx, CapEx. It pays to consolidate. I mean, you look at it, what you can do, and just think about the footprint that you're using right now compared to what you could be if you're running on AMD EPYC solutions. All right, enough about AMD alone. Let's talk about what we're doing with Azure. Let's talk about some of the solutions that we built specifically around some of the security solutions as well. So why are customers choosing AMD VMs? Performance, choice, user experience, economics, and one that's not listed here but should be, security. The portfolio that we've built with Azure incorporates these 4 verticals: general purpose, HPC, GPU visualization, and storage optimized. The DA and EA storage for the solutions on the left for general purpose are exactly the same platforms as the confidential compute VMs that Graham's going to talk to you about in a minute. HPC, GPU virtualization for accelerated DAS and AI, and then storage optimized high throughput database apps as well. With that, you get outstanding price performance for general purpose Azure workloads. The DA and EA solutions, along with the confidential VMs, simple use cases, the general purpose environment that is so popular within Azure. You can see here on the chart on the right showcases the gen over gen performance uplift from 3rd gen to 4th generation. If the 3rd generation doesn't necessarily meet your criteria, you've got another option associated with it, and you can migrate all of your x86 to AMD powered VMs without changing any code. And that's the same for confidential VMs. So how do you know if you're choosing an AMD based VM? We made it pretty simple. NVA, SV5, DA, SV5, you get the gist of it. But there are some exceptions with LSV2. So just keep that in mind and can give you a simple roadmap to pick those VMs. Price comparisons. We talked about the efficiencies from the TCO perspective, but then the end user. Nobody likes that awkward end-of-month conversation associated with potentially their cloud bill. This is a 16 CPU comparison, The general purpose with storage, without storage, roughly a 10 to 9% discount. Memory optimized, same thing there. With storage, without, 10%, 9% discount. But then look at the discounts associated with the confidential VMs. 50%. That's a huge, huge TCO advantage from the VM perspectives, working directly with Azure. Let's talk about some of the security features. And one of the main reasons we're here today with Graham and Azure for that matter. AMD Infinity Guard is the foundation of confidential VMs. Look at it kind of like a layer. You've got the hardware underneath and ultimately working its way up to the hypervisor and then incorporating it into the operating system, enabling specifics to SEV, which stands for Secure Encrypted Virtualization. You encrypt each VM with unique individual keys. This allows you to cryptographically isolate these individual VMs and really have a full root of trust in a cloud environment. SEVES, which is encrypted state, another layer of protection. This provides CPU register protection. And then SEV S&P, which is secure nested paging. Graham will highlight this is exactly where Azure chose to deploy and create their solution. For more information on this, and the devil in the details, developer.amd.com, there are white papers for plenty of reading material associated with it, as well as futures that we're talking about from an SEV case for the next layer of Infinity Guard. This is all based on our AMD Secure Processor. It's a dedicated security subsystem, 32-bit microcontroller. It's within the SoC itself. It runs its own kernel, improves security that way, provides cryptographic functionality, key generation management, and enables hardware-validated boot. Like I said, this is the root of trust. The hardware-validated boot, you can see on the right there, all starts with that PSP, load, authenticate, all the way from the power on. This, from a developer perspective, once you get the VM stood up, once Azure's provided that, there's attestation services that key into the VM itself, so you've got that all the way back down to the hardware. This is the very beginning of that process. And then hardware-based memory encryption. How do we actually do it? We can incorporate an AES 128 engine in the memory controller itself, all based on that AMD security processor. You can see secure encryption keys managed by that processor, not exposed to the x86. Guest OS chooses pages to encrypt, and no changes to user applications. Let me repeat that, no changes. You can port DA, EA, confidential VMs back and forth all day long and be able to use them accordingly with your existing code as of today. SME, secure memory encryption, like we talked about, one of the layers, and then SEV is that cryptographically isolated scenario. Just to kind of highlight the technology and where we're going with this, it's the 7001 series, which was our first product back in 2017. We incorporated 16 unique keys that could ultimately create individual VMs. Since then, so 7002, 7003 is 509 individual VMs from a confidential VM perspective. So we've exceedingly increased that. And then in the next generation, that doubles once again. So let's talk about performance in confidential VMs or standard VMs. You can see here, you get the data protection and the performance you want. You get minimal performance impact, no need to recompile applications, which saves time and money. Confidential virtual machines, same specs as general purpose for the DA and EA, like I highlighted, showcase the cost associated with each one of them. You can look at this chart here to showcase the individual performance. On the left is the confidential VM, the lighter blue. On the right is the 100% as the baseline associated with the standard VM. You get the Monte Carlo simulation, 2% performance hit. Black-Scholes, same there with 2%. And you can see the chart across the way, all the way over to core mark. At the end of the day, once again, you get the performance you need along with the protection. Some could argue that security is the new performance, kind of like the orange is the new black. We'll see how that works out. With that, I'd like to pass it off to Graham, kind of walk through the Azure confidential VMs. Thanks, Graham.
Awesome. Thank you, David. It's so good to see all of this great hardware innovation coming out of AMD that we can then go and in turn deploy into Azure. So I mentioned at the beginning some education. Just if you're not familiar with confidential computing, just from an industry landscape, I'll set up some context here. From a industry standard perspective, confidential computing is the protection of data in use while processing data in a hardware-based and a tested, trusted execution environment. We'll dive into what some of these terms are, but a tested is going back to some of what David said about having that root of trust. You can attest the hardware, you can attest what is running in Azure right down to the hardware. Not David specifically, but the AMD hardware. And it's truly revolutionary hardware that is really adding to that defense in depth for protecting your data while running into the cloud. There's actually a consortium that's in place within the Linux Foundation. That's the Confidential Computing Consortium, to define the standards, terminology, technology that the whole industry can rally around when it comes to confidential computing. This is encompassed with cloud vendors, hardware vendors, solution providers. So it's a whole industry momentum and participation in the open to define what confidential computing means for the industry and to take it forward in the cloud, on the edge, everywhere as the future of computing. Diving into what we have in Azure, we build upon what the Confidential Computing Consortium provides as the standards. Just to give you a little bit more context, if you think about the whole data lifecycle, this is data at rest, data in transit, and data in use. The first two already have solutions. This is where you could have disk encryption or TLS, and TLS covers data in transit. The gap that has always existed from a general computing perspective was protecting it while your application is actually unlocking that data and processing it in memory. This is where we are going that step above in Azure to push confidential computing to eventually be a standard across all of Azure. Again, there's components that can be completely removed from your trust boundary of your applications. This is all the cloud components where cloud administrators are involved, as well as sometimes your own administrators, even within a tenant. There's solutions that we can do in Azure on confidential computing that even protects your data from your own administrators deploying and operating your applications. We're also seeing new innovations, lots here in build with AI, and having the ability to say, well, we have these models and even proprietary IP in these models and their weights. Sometimes it's not just data in terms of patient records or financial transactions. It's actually the models and the weights of these AI solutions that equally need to be protected. This, again, could be from external providers, third parties, or your own administrators. So from an Azure perspective, we take our security bar and our defense in depth on data to the limits with a very high bar. We have that hardware root of trust that is actually outside of Azure through our hardware vendors like AMD. So even Microsoft's admins can't access those hardware encryption keys that are baked into the CPU. We also have that remote attestability so that you, within your applications or within your solutions, can attest and make sure this hardware is what's running in Azure. And it's a full layer. You can attest the software of your solution as well, so that you don't unlock your data for processing until that attestation returns true, and you know that it's running in one of these memory secured hardware-based environments with that hardware-based memory encryption. So here's a bit more of the stack, and we'll talk about that attestation as well as key management here. This is building on that base platform, that hardware root of trust that is outside of Azure, and then within the VM itself or a container. We can cover both workloads, VM level or container level with isolation. You can run an attestation policy to know that you're running in one of these secured environments, as well as have what we call a secure key release mechanism. This is only available in Azure, being able to have your keys locked within a confidential computing service, and then be able to only make your data decryption keys available into this secured environment. So you yourself can trust that the hardware is doing its job with the memory encryption, and you can have your own customer managed keys, be able to encrypt your data, bring them into the secured environment, do your attestation check, to know that it's one of these hardware encrypted protected environments, and only then when your attestation returns true or you're happy that it's running in this protected way, you unlock with your own customer managed data decryption. And everything that you see here outside of that VM boundary is not part of your trust equation. The hypervisor is completely outside of your trust. So the cloud components that we have that Microsoft administers is completely outside of the trust boundary of your application. Okay? With that, we have confidential VMs that have been available in Azure, I believe since last summer, so up and coming to a year now. I think it's about 10 months. These are based on those AMD EPYC machines that David went into lots of detail. These do have that ingrained hardware-based memory encryption with integrity, because in Azure, we wanted to keep our bar high, so we only deployed with SEV, SMP, the secure nested paging with integrity into our Azure confidential virtual machines. We're also the only cloud that has OS full disk encryption with these VMs so that you can encrypt your OS disks and that secure key release mechanism that I talked about. Attestation can also be done at runtime, not just when you're booting up your VM. So within the guest VM or within your application context, you can go and verify at runtime, am I still running in one of these secure environments? So over time, you can always go back and check. We also have our virtual TPM to seal secrets, as well as secure boot, so that you can make sure that only verified and signed code is enabled to be initiated as your VM boots up. I'm also happy to talk about some OS support here that's already exists with our confidential VMs. David mentioned some of the SKUs, so we have both general compute flavor as well as memory optimized for those memory intensive workloads. And equally already available in Azure today, we have Canonical with Ubuntu, as well as our Windows operating systems to be able to run within those VMs, both in US as well as Europe regions. And I'm happy to announce today that just now in preview, we also have Red Hat Enterprise Linux 9.2 available in preview. And coming this summer, we're expanding our regions to several more places where you'll be able to use these confidential VMs in Azure. This is all en route to us deploying new hardware with all of these confidential capabilities throughout different regions as we expand over time. I always say, if we could just instantly switch the hardware to new hardware, that would be awesome. This is where we're rolling out this new hardware as fast as we can to these new regions. Okay, I mentioned workloads can be containers as well as VMs. This is where I'm very excited today to announce the general availability of our confidential containers on Azure Container Instances. So this is our serverless environment. It always seems to me as the best of both worlds, where in a serverless environment, you're leveraging the cloud to do the full management, and you're supposedly giving up on security, but no, with confidential containers, you do get the best of both worlds, where Azure can manage the infrastructure on your behalf, and you can do the full isolation of your containers with full attestability, so that you can have full control of your data while running in even a serverless environment. And it comes with all of those serverless benefits too. You don't manage the infrastructure, as well as you can take advantage of pay per second billing. You spin up, use the infrastructure, spin down, and only pay for what you use. Additionally, because it's built on that AMD EPYC platform with the SEV SMP, it does have a full Linux kernel ability to be able to bring any existing application without modification, just like David mentioned. So we actually deploy it in segmented area. We call it a utility VM within the VM. So it's a lightweight Linux kernel that can run any application and be separated from the overall parent VM to give it that container level isolation. We're also bringing a bunch of that same technology and isolation into the community. Many customers would come to us and say, hey, I love the serverless. I also want to have my own managed containers and take advantage of Kubernetes management tools and orchestration. Well, I'm happy to announce that coming very soon is the same type of container isolation running on confidential computing in our Azure Kubernetes service. You can sign up for a preview with the link on the screen right now, and it has that same container level isolation, even from the Kubernetes admin. So even your own admins within your container deployments within Kubernetes, you could get that same level of isolation and data protection from your own admins or solution provider that's running in Kubernetes on your behalf. Again, AMD with their SEV SMP implementation can run any containerized app, no code modifications. And from my perspective, this is truly innovative because it's in the open. This is leveraging that Kata Containers open source CNCF project that already exists and creates container isolation is as part of the standard Kubernetes projects. And then now just extending that to be available with confidential computing infrastructure. So Azure Kubernetes service already supports Kata containers in preview, and now we're working to get the confidential computing backing with those containers as well. For me, this is just truly revolutionary and also fantastic to see the companies coming together in the open, developing within these open source projects. One example, going back to our containers on ACI, it's exciting to see some of our ISVs already deploying solutions and in the AI space. So here's a company that is one of our partners, Azure Security. They're already using our GA offering of Azure container instances with confidential containers to go and do AI and large language models for their customers. So already realizing some of these deeper defense security benefits for customers trying to do AI in regulated and sensitive places like healthcare. So super fantastic to see solutions already becoming real when we just announced GA this week. Okay, let's talk about another layer up the stack, some services that are available. Many customers would come and say, great, we got the infrastructure. How about running some of these Azure services that we know and love? We do have existing offerings that you can go and run SQL Server on our confidential VMs, as well as Azure Virtual Desktop running on confidential VM SKUs as well. I'm super excited to announce today that now we have in preview also Azure Data Explorer as well as Azure Databricks, both enabling the ability to run on our confidential VMs in Azure. So from that perspective, there's so many Azure services that use Data Explorer. Some folks might be familiar with Kusto, if I refer to that, Kusto and Kusto Query Language. This is so heavily used for logging and telemetry-based analytics. So I'm very excited to see this type of service come in and be able to run on our confidential infrastructure. Equally, you folks can go and start leveraging these SKUs, and I'll show you how. Azure Databricks is for Spark-based workloads with data analytics, where you can now run your Databricks compute clusters on these confidential VMs powered by AMD SEV SMP. Let's go through a couple quick demos. Sorry we can't do in-depth demos. If you want to see some of these demos, they are full-length versions in the AMD showcase. I'll go through a couple quick views so you can just see, hey, within the Azure portal, this is what the SKUs look like. So ADX, Azure Data Explorer's clusters, can be configured with Azure Key Vault with customer-managed keys for encryption, as well as user-managed identities running on ACC or our confidential VMs. So when you're doing your cluster setup in the region, you just set up your region and your VM SKU. When you're searching for your VM SKUs, we covered some of the SKUs here today. So again, you're looking for the ECA with the little a. When you're picking your specific SKU, you'll be able to see it here. It's in the dropdown and it has a little lock icon. So that's how you know it's one of these confidential computing enabled VMs. So there the EC8A is picked. It's as simple as that. You can review your cluster and do the deployment. And now your Azure Data Explorer workspace is created. Once that deployment is done, you can then enable that data encryption to combine with your customer managed key for encryption on your data. You point to the key vault store that has your customer managed key, and then you can assign it to the user identity that has access to that customer managed key. So then once you get all of those configurations in place, the result is a confidential ADX cluster with your own customer managed key controlling that data encryption. Again, and that's still running on that memory encryption provided by our AMD hardware. All right, same thing with Azure Databricks. They can run on confidential VMs. I'll go through this one quickly. So after launching your Databricks cluster, your Databricks workspace, you configure it with a new compute cluster that has the ability, again, to now select these confidential VMs. So you just need to know the SKU. Here, the worker node is set up as an EA SKU, the memory optimized, and then the driver node is set up as a DA SKU, a DCA SKU, which is the general compute version. So then same thing here. I'm not going to show it in the demo, but you can combine this with your customer managed key to establish a custody to enforce that encryption throughout your workload, extending from what was available at rest to now also cover data in use with confidential computing. Okay. I keep saying also, but I'm also excited to announce some really, really interesting partnerships. It's not just the Azure Services. We're also working with third-party partners, AMD, Azure, as well as SAS as one example, to get more of these solutions and workloads running on confidential computing. So SAS VIA is an AI and analytic and data management platform, particularly in healthcare and finance. These are leading innovations that are now going to run on confidential computing through the partnership that was just announced this week. So regulated and sensitive data can now start running with this defense in depth and protection while running in the cloud. Also, if you'd seen an interview, I got to meet the Chief Product Officer, Matt, from Habu today. Very excited that Habu Data Cleanrooms is just announced this week to run on confidential VMs powered by AMD. So many of the customers that I talk to end up wanting to do multi-party data collaborations, whether it's model from one party, data from another, or multiple sets of data that want to be combined for joint analytics. These are all what we classify as clean room type operations. And there's so much legal red tape that needs to be done in order to actually get companies to combine data together, and there's often unwillingness to share data. Well, with clean rooms and then running them confidentially on Azure Confidential Computing, we can unlock more of these innovations to be able to happen so that companies are able to each bring their own attestation policies, combine their data, know that the environment is secured and hardened and not going to expose any of the data or insights to any of the participants, and then be able to then say, yes, now you can unlock. So each party can contribute their own policies and attestation before the data is allowed to be unlocked and processed. So again, some very, very powerful opportunities with confidential computing running on top of these confidential VMs provided by AMD. This puts a lot more data into the at the fingertips of people that might not be able to access it today. Okay, with that, we can spin to some questions, some call to actions here to start. There are some demos available. If you're here in person, you can go check out the AMD Partner Showcase. As well, there's a celebration, if you're here in person tomorrow, that AMD sponsored a VIP celebration. If you're here digitally or online, on demand, go check out some of these services that we talked about. SQL Server, Azure Virtual Desktop, Data Explorer, Databricks. All of these services now support running on these confidential VMs. We have a link to a blog here that summarizes some of these announcements. I encourage you to check out. I think we have some time for some questions here. If you're in the room, please use the QR code, which is, oh, sorry, I missed one thing before we go to questions. There is also an Ask the Expert session. So if we do run out of time for questions here, there is a digital session that's available in about half an hour that you can join and really ask the true experts. David and I are here as spokespeople in some regards. So really good experts are on the line if we run out of time here. So with that, if you do have any questions in the room, we can take them in the room or online through chat.
It is pretty cool to see. I mean, like you said, about how long ago from a research project, it's amazing to see these solutions come together, and even with the customer testimonials today. So, I mean, it's fun.
It's real now.
It's totally real.
Yeah.
And in the future, beholds, looking at standard VMs as of today, even working with, Mark Ruzinovich from Azure, his vision and publicly stated recently, confidential VMs are the VMs of the future. So learning what you can now, getting on, working with them within Azure, this is the time to address it. Looks like we've got a couple of questions.
Yeah,
take the
come
first
on
one.
over here. Sure. So it says, what are some of the scenarios for which customers are developing solutions on confidential VMs? I love this question because I love talking with customers. So I would typically bucket customer engagements into two. So one set of customers would come to me asking, hey, I'm trying to migrate to the cloud. I have sensitive data, and it could be regulated data. This is very heavily in the EU, to be honest, where there's more stringent regulation in place. And the discussion is more around how can I bring my workload to the cloud to run on confidential computing. I want to be cloud first. I want to bring as much of my workloads as possible. I'm stuck with regulations or compliance. And confidential VMs can help unlock more of those workloads.
It just opens the door
Yeah.
for previous workloads that you just, didn't have that at a station. You didn't have that trust zones at Kerr, but this just opens the door for all of that to be able to provide and really potentially scale your business from your, what compute power that you do have that you didn't have previous access to.
Yeah, and then the other bucket that I would say is some of these new innovations, these multi-party, multi-companies working together to either combine data or, again, AI scenarios where company A is bringing model, company B is bringing data, and being able to innovate together with others while protecting data across organizations or protecting IP in the case of models and model weights. So this other group of scenarios is really more of these new scenarios, new innovations that were deemed not possible in the past. So it's very exciting to see some of these new solutions becoming possible with the help of confidential computing.
Yeah, generally healthcare, financials,
Yep.
Just really that high security environment that you really just have to have that trust.
Or regulated data where
Yep.
privacy compliance needs to be met.
Exactly. All right, the second one, I'm going to let you handle that one as far as what is the process for migrating standard VMs to confidential VMs? So you're up and running right now.
Yeah.
How do you migrate over?
Yeah, so there's typically two migrations. It's one, you're coming from on-prem, or two, you're coming from a cloud environment where I don't want to say non-confidential. Azure is so secure already. This is more just adding that defense in depth right down to the hardware with the VMs. So the migration process is quite simple. There's the same VMs like was introduced right at the beginning. The same SKUs are available with the same specs, just the memory encryption enabled variant. You go from a DA to a DCA. And you can swap your workloads over onto these VMs. And these have that same characteristics as a general compute VM, or for that matter, on the memory optimized side. So just using the VM infrastructure, you can swap from one to the other, and then you get to choose what level of control that you want to have, where you want to apply attestation, if you want to use platform attestation versus your own custom attestation. There's lots that can be customized, disk encryption versus customer with platform keys versus customer managed keys. So you can take advantage of certain features that put you more and more in control and tighten your security boundaries. So trade-off of ease of use versus really tight controls, but in all cases backed by that memory encryption and confidential computing backing. So a lot of those capabilities are available in Azure, and it's just a matter of which features that you want to take advantage of. Okay?
Looks like we got another one. What AI scenarios are you seeing Azure confidential computing used for?
We brought up a couple of those protecting model scenarios. I love the ones that are impactful to people's lives, right? So when we're in healthcare and we see clinical AI desire to be developed, but there's holdbacks because data is not available, or models can't be trained well enough because there's no real world data. And I'm seeing more of these solutions and partners within our ecosystem be able to unlock more of this real world data for training models. And it's super exciting to see because it can expedite getting AI readily available in some of these even regulated industries like healthcare. So getting these models, getting models that are highly performant with real world data into the hands of clinicians is fantastic because healthcare outcomes only improve. And then obviously there's impacts like being able to save lives. So that's where I, step back and say, wow, we're really making a difference with some of the hardware and innovations that are coming to Azure with confidential computing with the help of AMD.
And I think this is just the beginning for it too. I mean, once people really understand this environment and what they can do with it, in the sense they can trust it, and it fully end to end, as we've described here, it just really kind of opens that door even more.
Yep, absolutely. I'll let you take this one.
All right. What is the performance penalty for using SEV SMP? We highlighted that in one of the slides specifically, for the data performance. Really, from the far left, that 2%, to the far right, the chart that incorporated roughly, that 4 to 6%, but depending on some of those benchmarks that were showcased there. So in general, it is workload specific, but at the end of the day, you still get relatively good performance associated with the confidential VMs based upon how we've got them deployed.
Yeah, and I'd also add on, this is the future of the industry in terms of the standard and expectation going forward. So if we have this North Star where the future of computing is just confidential computing,
yes,
and then we call it computing again, because then you won't need to use the word confidential. But from that point of view, Azure, our hardware vendors, we're all working together to bring no sacrifice in terms of being able to leverage this memory encryption and confidential computing capabilities. So again, the North Star, it will be pervasive, and there will be no questions to ask around performance differences, cost differences. It's all just going to be de facto and pervasive. So from that point of view, where we are today, I'm just confident it'll only keep getting better. Agreed.
One other avenue that we're looking into and currently developing right now along with Azure is around kind of secure I/O and SEV I/O. It's technically SEVT I/O, and that is, we've got a white paper published on developer.amd.com/SEV, like I referenced earlier in my slides. That showcases kind of that next level layer that we're looking to. That specs out there will be, it's very similar to SEV SMP from an ecosystem perspective. It takes that endpoint device and adds that to it as well. So we're continuing to progressively add more security from a foundation, from the core all the way out to some of these I/O devices in future generations. So like I said, learning what these confidential VMs are, how they impact your business, how you can use them compared to what I classify as a standard VM today. This is the time to dive in and really, address what you can do with them and how you use them.
All right, I think we got time for one quick question. Are confidential VMs available worldwide? What do you expect for a worldwide rollout? So from that point of view, there was a slide here. We are in a couple regions in the US as well as Europe. And then we have targeted regions that we're going to: Southeast Asia, Switzerland, Italy, Japan, in the next couple months, US summertime. So it's all part of the journey in lighting up with more customers. And as we get more hardware available and the ability to go increase our capacities in different regions, we'll see them start to deploy in more and more regions over time. So I'm very excited for new regions to light up this summer. And then again, the North Star over time, it will just see pervasiveness with our confidential VMs in every region, and in the longevity of things, every workload is just projected to run on confidential computing infrastructure, whether you take advantage of all the bells and whistles and user controls or not. I think we're wrapped up here. We're running out of time. So do you want to go back to here's the calls to actions if useful or not. But thank you everybody for joining online as well as in person. Again, enjoy the rest of the content from Build.
Thanks all.